Alright, boys and girls, willkommen till Bakelton drive-through, ladies and gentlemen, for a special Norwegian version of the drive-through, brought to you by Norway. Visit Norway. Enjoy the fjords. Tusen takk. Alright, this is all about circles today. 10-1, the circle. Alright, so I know you know lots about circles, so this will be a quick video, but there's probably some things you never thought of, so just kind of stay with us. First of all, you need to be able to define a circle. So a circle is the set of points. It's an infinite amount of points that are equidistant from a set point called the center, but you have to say that it's in a plane. So, by this definition, you got a center, and you got a bunch of points that are all the exact same distance. And if we took all of those points, you'd have your circle. But if I crossed out this, then hopefully you can imagine we would have many circles, and you'd have a sphere. Okay? So, that's the difference between a circle and a sphere, is a circle is in a plane. Alright, concentric circles are circles that share the same center. So think about those like a bullseye. Okay? And, you know, maybe you can use your foreign language ability to see that concentric means with center. So all of these circles have the same center. Alright, moving on. So, the interior and the exterior of a circle. This is often misunderstood. People sometimes think this whole thing is the circle, and that's not true. The circle are the set of points equidistant from a set point called the center. So these points are on the circle. This is the interior of the circle, and this is the exterior of a circle. Okay? So that's just a concept that you should understand now. Alright, so that's a chord. So how could we define chord? Well, it's the set of points, it's the segment with, oh my gosh, exactly. I'm not going to use that feature anymore. It's the segment with endpoints that lie on a circle. Okay? So, using that definition of a chord, what's the easiest way to define a diameter? Well, a diameter is the longest chord in a circle. Or, it's a chord that contains the center of the circle. Man, I am nervous right now. Okay? And a radius is defined as a segment, not a chord. A radius is not a chord. It's a segment with one end point on the center of a circle and one end point on the circle. And it's just a fact that a radius is half the measure of the diameter, but that doesn't go into the definition. Okay, moving along. So, hold on on a sec. So now we're going to go with 3 theorems about chords and radii. So here's a nice little feature. If you've got a radius and you've got a chord, so if you've got a chord that's perpendicular to a radius, you've got some special things going on, okay? So here we've got a chord. So the first theorem is if a chord is perpendicular to a radius, then the radius, any guess? Bisects the chord. Okay? The converse of that is the second theorem. If a radius bisects a chord, then it is perpendicular to the chord. And then finally, the third one that says if a segment is the perpendicular bisector of a chord, then that segment must pass through the center of the circle. So you might want to pause that and add those to your notes. Those are the 3 major theorems of today. The first 2 theorems are just converses of each other, and the third one's kind of something you should probably consider and think about before you start your homework. Speaking of that, let's do one example problem with a Widmapoi, and then this video will be over. So we've got a circle with a radius of 13, and then you've got a chord that's 10. I'm going to strategically draw this radius because I think that's going to matter. Okay? What is the distance from the chord to the center? Well, this is what we're looking for right here, that distance x. And we know that there exists a radius that would bisect this chord. So this would be 5, and that would be 5. And we know that this is the radius. That must be 13. So I see Janet Jackson here, but just in case you don't know what that is, you got x squared plus 5 squared equals 13 squared, okay? So x squared equals the square root, x squared is 13 squared minus 5 squared. So x is the square root of 169 minus 25, which is the square root of 144. X is 12. So this chord is said to be, from here to here, 12 units from the center. Can I get a boom, study hall? Boom!